Half a mountain disappeared in a matter of minutes. Billions of tons of ancient volcanic rock gone. And the ocean, with nowhere left to go, did the only thing physics allowed. It rose. What followed was not a wave in any sense that word is normally understood. It was a rearrangement of the sea itself. A wall of water measured at up to 20 meters or more, arriving at inhabited coastlines with zero warning, zero mercy, and zero chance of escape. And the most disturbing part of the entire event is not the scale of the destruction. It is how quietly it began. Welcome back to Dark Ledger. That certainty was about to be annihilated. Volcanic islands like Ritter are not built to last. They are assembled fast and assembled steep, layer upon layer of lava, compacted ash, and fragmented rock, stacked upward under enormous gravitational stress. Beneath the surface, hydrothermal fluids, superheated water laced with dissolved minerals, circulate constantly through the rock mass, chemically corroding it from within. A 2019 study by researchers at the Geomar Helmholtz Center for Ocean Research Kiel, published in Earth and Planetary Science Letters, confirmed what structural analysis had long suspected. The western flank of the volcano had been deforming slowly for decades before 1888, shifting outward under its own weight in a process geologists call sector collapse. No surface cracks, no obvious warning signs, just a mountain quietly losing its structural integrity, one dissolved mineral bond at a time. On the morning of March 13th, that process reached its terminal point. The first thing people reported was a sound. Not an explosion, not the thunderclap of Krakatoa, which had devastated the region just 5 years earlier in 1883. This was something different. A deep, low, resonant concussion rolling across the water. The acoustic signature of an estimated 4 to 5 cubic kilometers of rock, based on early modeling by Ward and Day in their 2003 landmark study in Geophysical Journal International. Detaching from the island's western flank and plunging as one catastrophic mass into the ocean below. In minutes, the largest part of Ritter Island had ceased to exist above the waterline. And then the sea did something that made no sense. Along the surrounding coastlines, the water began to retreat. Shorelines pulled back. The seabed was exposed where open ocean had been moments before. Fish were stranded in wet sand. Children ran toward the receding water, drawn by the impossibility of what they were seeing. Boats settled crookedly onto the sudden ground. It was a drawback, the suction phase of an incoming tsunami, as the ocean is essentially yanked toward the displacement zone. It is one of the most deceptive phenomena in all of natural disaster science. Because the moment it begins is precisely the moment to run. Those who ran survived. Those who stayed to watch did not. The first wave arrived within minutes of the collapse. Based on the volume of displaced water and the physics of landslide-generated tsunamis, modeled in detail by researchers at the Guiomar Helmholtz Center for Ocean Research Kiel in their 2019 study. The initial wave heights near the source would have been significantly larger than what reached shore. By the time it reached inhabited coastlines on New Britain and surrounding islands, it had lost significant energy. Run-up heights of more than 20 meters were recorded on the neighboring islands of Umboy and Sakar, with destructive waves observed more than 600 kilometers from the source. On New Britain, the surge pushed inland for up to a full kilometer, flattening every structure in its path. Villages were erased. Coastal forest was stripped from slopes far above sea level. Fish were later found lodged in the branches of trees that survived, mute, impossible evidence of how high and how violently the water had climbed. An estimated several thousand people were killed across New Guinea and the Bismarck archipelago in a matter of minutes. But the first wave was not the disaster. It was the opening act. Observers recorded the sea rising and falling repeatedly for hours, with witnesses at Finschhafen, some 350 kilometers from the source, documenting waves of up to 8 meters arriving at 3-minute intervals for as long as 3 hours. As recorded in the Warden Day 2003 study. Wave after wave, each one surging inland, retreating with debris, and returning with renewed force. Hundreds of kilometers away, ships at sea logged unusual surges in their navigational records. Distant coastal settlements experienced repeated flooding through the afternoon and into the evening of March 13th. The ocean did not calm for hours after the collapse. It could not. The energy was already inside it. Today, Ritter Island remains in the Bismarck Sea, but it is unrecognizable from what it was. Where a symmetrical cone once stood, there is now a crescent-shaped remnant. The surviving eastern arc of the volcano, curved around an absence. Seafloor mapping by the Guiomar Helmholtz Center for Ocean Research Kiel, conducted during the 2016 research expedition aboard RV Son. Reveals a debris field extending more than 70 kilometers from the source. Massive blocks near the collapse zone, giving way to finer sediment further out. The entire landslide preserved on the ocean floor like a frozen crime scene. Approximately 4 cubic kilometers of the volcanic edifice. Still there, beneath the surface of the Bismarck Sea. There was no eruption, no massive seismic event, no atmospheric warning that instruments could have detected. There was only the slow, invisible exhaustion of a structure that had been failing for decades. and then a single morning in 1888 when it finally, completely, let go. The ocean doesn't need a reason, we understand. It only needs the land to fall into it.